Hi, pre-calculus students. Okay, last part. Well, I don't know what order you watch these in, but we're going to do, this is my last video for chapter 11. Yay. So talking about solving equations. All right, so if this is the first video of these three that you're watching, I'm just going to go over the three different types. So when you're solving an equation involving maybe logarithms, it could be one of three types. So it could be an exponential form, where the variable is an exponent, in which case you want to get the base with the variable alone and then either take the log or natural log of both sides. It could be where you have log base b of something equals log base b of something, and we're going to set those two somethings equal to each other. That's what we're going to talk about in this video. Those are examples B and D. Okay, in this case, you may need to use log properties to condense one or both sides. The third case is if it's in logarithmic form, log base b of x equals y. In that case, you would want to rewrite it in exponential form. And again, you may need to use log properties to condense more than one side. All right, so we're going to do examples B and D right now. So notice how in example B, we have log, and this is like base 10 of 2x plus 5 equals log base 10 of 5x minus 4. Well, in order for these two sides to be equivalent, this expression has to be equivalent to that expression. And so what we can simply do is set those two expressions equal to each other. It is not that you are canceling the logs from both sides. A log is like an operation. You're not canceling the operation, but it is true that these two expressions have to be equal to each other. Right? Well, knowing that, we can just solve that equation, right? So we can subtract 2x from both sides. We can add 4 to both sides. And so we would have 9 equals 3x. And so then x is 3. So pretty straightforward. Okay, now when we look at example D, I see logs on both sides, but that equality rule is that you have to have log of something equals log of something with the same base. And over here, I have two different log expressions. So remember how I said we might have to condense using one of our log properties. So that's what we're going to do. I see that these are being added, so I can rewrite it as log base 11 of a single product. Okay, and I could, at this point right now, if I wanted to simplify inside those parentheses, notice that it's the log of that entire thing. So that's the log base 11 of x squared plus x equals log base 11 of 6. And then at that point, I can set those two expressions equal to each other. So I have x squared plus x equals 6. I notice it's quadratic, which means I'm going to have to either factor or use the quadratic formula. This is an easy one to factor because the coefficient here is 1. So I can think of two numbers that multiply to be negative 6 and add to be positive 1. So x plus 3 times x minus 2. And then when I set my factors equal to 0 and solve, I get negative 3 and 2. Now this one is a little bit unique because I got a negative answer. Remember, you cannot take the log of a negative number. And if I put negative 3 in here or here, I would be taking the log of a negative number. So just like when we had rational equations, sometimes we'd have extraneous solutions, numbers that would make the denominator 0. That's happening here too. So our only solution in this case is x equals 2. All right, so if you want to see the other examples, please watch the other videos.